Welcome to another set of video notes. Now today's set is going to be a little different, and maybe you figure that out from where I'm standing on the board, because today we're going to be using our projector and looking at some graphs. So hopefully that works fine for you, but there's going to be a little more movement on the screen. So if you tend to get motion sickness, this is the time to stop, go get your Dramamine or your 7-Up or your saltine crackers, whatever stops that feeling of throwing up. Because I would never want to be accused of making you throw up while I give you notes. So here we go. 2.6, we're going to look at how to draw scatter plots and best fitting lines. This may be something you've talked about in Algebra 1. Unfortunately, sometimes when teachers are getting towards the end of the year and they're shoving all kinds of stuff in, this is a topic they skip. So I don't know how many of you know about it and how many of you don't. The one thing that I want to make sure of is that we all hear about it and get good at it, because you will use it in other classes. It's used a lot in science classes, particularly chemistry, biology some, definitely physics. So as you go on, the more familiar you are with this, the easier it'll be. If you come back in a year or two and take statistics, you'll do this again, so you might as well learn it now. All right, so the first thing we need to talk about is the term correlation. Correlation sounds pretty fancy. It's just a way of saying there's some kind of relationship. And for us, it's going to be a linear relationship. Okay? So, if you look at this graph, what seems to happen? Well, as the x gets bigger, so does the y, or they seem to go up. We say this has a positive correlation. Another one you might see is like that. Oh, these seem to be going down. The bigger the x gets, the smaller the y gets. So this is negative. If you look at the graph and there's no pattern whatsoever, then we say there's no correlation. What I'd like you to do is look at this overhead. We've got some graphs we're going to look at. Okay? Here's my question. Describe the correlation shown by each scatter plot. Now, I'm going to tell you, for the purpose of notes, I'd like to see that you tried answering them. I get that I won't be able to tell if you wrote it down beforehand, but I'd like you to try this with me, okay? So we look at this. This is how many subscribers in millions and how many service regions there were. And this is some old data, but that's okay. What seems to be happening? Well, as this gets bigger, what happens to the y? Right now, I'd like you to pick positive, negative, or none for the type of correlation, and then I'll show you the answer. Did you come up with your answer? Theme song of Jeopardy? It's time. Oh, and here's another one. I thought I was going to show you the answer. It didn't. It showed you another graph. So we're going to call this graph 1, and we're going to call this graph 2. I want you to decide right now what you think of the correlation. Okay? Are you done? I bet you are. Okay, so let's go on. What did you say for this one? You said positive? Oh, you guys are getting so good at this. And what about this one? You said none? Oh, you were not. Right. Oh, you said negative. Great. You got it. All right. Generally, getting bigger. One gets bigger as the other gets bigger. Here, as one gets bigger, the other goes down. Kind of like the idea of slope, positive and negative. Good. Okay, we're not going to worry so much about the solution, but we're going to talk about something else now. So now we get to shift back. Correlation is so important, it can get a coefficient, and we symbolize that with R, because that makes total sense, right? Correlation would be R. That's how mathematicians think. If you notice, there are a couple R's in there, so we'll go with that. R can range anywhere from being -1, exactly -1, all the way up to +1. If it is a -1, it is going to be a perfect, straight line with a negative slope. Okay? And I bet some of you can come up with what we should write under this one. It's going to be a perfectly, or a perfect, should really say perfectly, I guess. Perfectly straight line with a +1 slope. Just say a positive slope, that's good enough. Okay, so we're going to practice this a little. If you look at my examples, we're going to decide whether the correlation coefficient for the data is closest to -1, -0.5, 0, 0.5, or 1. So if it is that perfect straight line, we're going to say -1 as long as that's what the slope is. If it's that perfect positive line, we're going to say 1. If they're all over the place, we're going to say 0. And this is kind of in between perfect and all over the place, or all over the place and exactly that positive, okay? So let's look at some graphs. What do you think of this one? Yeah, this one's kind of crazy. Do you think this is negative or positive? Hopefully you're getting that this has a negative trend to it. There's kind of an idea, right? There's maybe one or two that don't follow it. So yeah, I'd say -0.5. Okay? And actually, it turned out to be -0.46. So we did great estimating that. Let's look at one more. Now what about this one? Now this one seems a little bit crazier. Let's see. Yeah, you're right. I think we should go with that 0. Because it's just, you know, you could say, well, these are getting better, but what about, getting bigger, but these, they're kind of crazy all over the place. Okay? So hopefully, you're getting better. Let's do this one. What do you think about this one? First of all, you might want to decide positive or negative. Okay? Are you thinking positive? Oh, I'm positively thrilled that that's what you came up with. Now, how close is that to a line? Do they look really close? Or are they kind of just generally? You're thinking close? Well, if you're thinking close, you are right. The actual value is 0.98, so that kind of gives you an idea what that's going to look like. Okay, we're going to just do a couple more practices. We're going to decide if they have positive, negative, or none, and then we're also going to tell, would it be close to -1, more like a -0.5, 0, 0.5, or 1. So for this one, what do you think? You can rule out negative. I think there's kind of a pattern there, don't you? So I'd say positive. Now, do you think it's going to be +1 or positive 0.5? Yeah, 0.5. Kind of a little too crazy to be 1. All right, let's try another one. What do you think about this one? Definitely negative, and I think, are you thinking -1 because it's close to that perfectly straight line, or are you thinking more like -0.5? You're so smart because you knew it was -1, didn't you? Okay, good. What about this one? Are you thinking no correlation? And if that's true, then you automatically know your R is 0. Okay? Hopefully that was helping you. Now, we've got to talk about some other things before we can move on. So let's do that. What we're going to talk about now is line of best fit. So you looked at a whole bunch of graphs before, and now we want to talk about, yeah, so what? Well, when you go to do line of best fit, I want to go over the steps with you. The first thing you have to do is draw your scatter plot, okay? And scatter plot is really just a fancy term for an X and Y graph. So you're going to just graph all your points, okay? Then what you're going to do is you're going to draw in the line of best fit. So take a ruler, take a straight edge, whatever you want to call it, the side of a piece of paper, the side of your iPad case, whatever. You're going to put it down on top of your data. Let's go over all these steps first. I know this might be confusing. You're going to put it down. Here, I'll give you just a little one. Okay? Well, you're kind of looking for where do I go in the middle of it, okay? So maybe I think this is kind of the line of best fit. Okay, so I draw that in. All right, then you are going to use 2 points on your line. And if you have 2 points, can you come up with the equation of the line? Of course, because we learned that in lesson 2-4. So first you're going to find the slope, like we did before, and then use the slope and 1 point to find the equation. Okay? So far so good? All right, because then what I'd like to do is I'd kind of like to practice this with a problem. Okay? So here we go. Oh, hello. All right. Oh, let me go back. All right, so I've got some alternative fueled vehicles. It shows you the number in thousands of alternative fueled vehicles in the years after 1997. So this is 97, this is 98, 99, 2000, 2001, 2, 3, 4. Now, I'd ask you to approximate the best fitting line for the data. Okay? So, first things first. We would have to graph all these points. Okay? So I'll show you that. Well, I'm going through the... Okay. So I drew in all the points. And then you're going to kind of put your line in. Now I think it kind of goes right in through there. Okay? And if you notice, it's hitting at 1 and 3,000, because this in 300,000, I should say. And then this one's hitting at 7 and 548,000. Okay? Now, this is not the only line of best fit. And years from now, you'll find out that there's a way to get exactly the line of best fit and why it's that way, especially if you take stats with me. But at this point, I get to tell you that there can be lots of different answers. Now, granted, if you laid your line down and made it go like that, that's not it. Okay, but if you just generally follow the pattern, there are going to be more than one choice. Okay, so now you've got 2 points on the line. You know how to find slope. You're going to take 548 minus 300. That's going to be 7. That's going to be over 7 minus 1. Okay, so we find our slope. It's about 41, and you can do some estimating there. Then we're going to put that into point slope form. So we put our 300 in for Y1. We put that 41.3 in for M. And we put our 1 in there. Okay? Now, you know how to work this out. You're going to distribute it. And then move this over. And here's the equation of the line. Okay? Now, some of you are going, do this all that much. Okay, the other thing, what's that other thing I always want you to bring to class besides your book? It's powerful, does some calculations. The graphing calculator. This is perfect for the graphing calculator. So we're going to end this video clip before it gets too long, and then I'm going to ask you to go to the second video clip right away and watch it. Okay? All right, see you in just a few minutes. Bye.